Hello, everyone. So, my name is Caur. I'm digital manufacturing engineer at PMC, working with the implementation of digital factory projects focused on robotic simulation, ergonomic simulation, and discrete event simulation through PLM's platform, especially with Siemens Technomatics platform. I have 10 years experience in this simulation world, and the vast majority of my projects were aimed at the automotive industry. So let's get started. That's the agenda for today's webinar. I'll be start by introducing simulation. We'll explore the capabilities of simulation software, economic benefits of using simulation. I will also present to you three real case studies. These are three projects that we worked on at PMC. One with robotic simulation, the other with ergonomic simulation, and the other with discrete event simulation. We'll cover return on investment calculation and justification. We'll overcome some common objections. And then we have the conclusion of the webinar and to wrap up a Q&A section. So let's start by a simulation overview. Right. So what is simulation? So simulation is the process of creating a digital model to replicate real-world system or process, so be able to study, analyze, and optimize it without the need for a physical prototype. So you can run multiple experiments on the virtual system to explore different scenarios, to predict outcomes, and to improve design or processes. We have different types of simulation. It can cover a wide range of fields like manufacturing, healthcare, robotics, ergonomics, logistics, and much more. But during this webinar, our focus will be on robotic simulation, discrete event simulation, and ergonomic simulation. So let's jump to a robotic simulation overview. So robotic simulation is a digital manufacturing solution that allows us to build, test, and validate a 3D manufacturing environment and to perform simulation of industrial robots. So we're able to simulate complex robot work scenarios. We can check interlock conditions. We can check for possible mechanical interfaces and also optimize the robot cycle time. It is mainly used in the pre-planning phases of a project where everything can be tested and validated even within a controlled environment. So the problems can be detected in advance without impacting the real environment, and the problems with the new installations are avoided. But we can also use it for existing installations. For example, we can create and we can test scenarios in order to identify some possible improvement proposals. So we can simulate complex robotic cells, for example, with several robots working simultaneously in assembling a product in areas with very limited space and which will be very complicated and will take a lot of time to program these robots in the real environment. So here we make sure that we won't have any kind of collision, we will avoid accidents. And if we locate any kind of interfaces, then we can adjust the trajectory of the robot or we can reposition the robot. And all of this while we are in a virtual environment. So we will avoid all these costly mistakes. Here I have listed some of the robot operations that we can create. So we have material handling, spot welding, sealant application, stud welding, and pedestal applications. Here we have some robotic simulation capabilities. So I listed here the robot path creation, so we can create the robot's trajectory. We can import a point cloud file. It's POD file extension. So imagine that you just scanned the work area where you want to implement your robot. You can import this point cloud file into the simulation software. You can import the robot, and you can define collision zones between the robot and the infrastructure, for example, or between the robot end effector and the infrastructure. We also have offline programming. It means that we can parameterize the robot's path with real speeds, movement types, clapping opening commands, welding commands, and release signals. We can also work with collaborative engineering. So it means that the projects can be stored in a database, and several engineers or different departments can work on developing the project under the same file. Now, let's jump to Discrete Event Simulation overview. So Discrete Event Simulation, or DES, is a way to model how things happen in a system over time, where things change at specific moments and not continuously. So for example, imagine that you were running a coffee shop. So we have customers, cash registers, and coffee machines, for example. These are the entities of your system. Now, different events can happen at different times, like customer arriving at the counter to order, or customer just finishing paying, and a coffee machine finishes making a coffee. So we have all these uh, um, entities in your system. So we have entities. These are the things in your system. We have events. These are things that is happening at the system at specific moments that are changing the behavior of the system. And we have time, and the time in the discrete event simulation moves forward in jumps or steps. And we have states, and the states is showing what's happening at a particular time. For example, how many customers are in the line, or how many coffee cups are being made. Here we have an image from a discrete event simulation software. So we can see some buffers, some assembly stations, some workspaces. We have shift calendar object where we can define work shifts, worker pool here, some data tables. This is just an example. And why is it useful? So we can use DES to test different things without impacting the real shop. So we can experiment different scenarios, create some what if scenarios, and see how the system behaves. So in other words, the simulation helps people make smarter decisions by showing what changes are needed and when to make these changes. So we can test different scenarios and outcomes before making the changes in the real world. And another thing is, it doesn't just offer suggestions, right? It will give us data and numbers to support those suggestions. So you'll be confident in your decision instead of just guessing. So here we have something that the DES can answer. It's not limited to, but we have visualization of plans, analyze capital investments, over/under utilization of resources, evaluating system robustness, understand systems, model uncertainties, quantify the impact of operational uncertainties, for example, downtimes, analyze and identify bottlenecks. So here we have an example. We have the original hangar, and we have a what if scenario. What if we have a hangar with a 2-tire capacity? Some examples of charts that we can collect from discrete event simulation. So for example, we can see stations or machines. We can see some working percentage here, waiting percentage, blockages. So we can see machine utilization, worker utilization, WEEP, jobs per hour, jobs per day. These are things that we can collect from this type of simulation. Now, here we have some other images just showing some other different what if scenarios. What if we add another station? What if we share the activities of these workers? All of this we can do by using discrete event simulation. It means that we can test an experiment in a risk-free way at virtually no costs in a fraction of the time otherwise required. Now let's talk a little bit about ergonomic simulation. It's another overview here. So ergonomic simulation refers to the use of software to analyze and evaluate how people interact with their workspace, with tools and tasks. So the goal here is to check some factors like posture, movement, and operator comfort to reduce the risk of injury. So it's possible to create realistic simulations, design workstations in the 3D virtual environment, and validate the workstations for operator comfort, taking into account injury risk, reachability, line of sight, energy, and fatigue. Here we have some ergonomic simulation capabilities. So we can model and size the virtual humans. It means that we can customize the whole avatar. It means define height, define weight, whether it's male or female, foot size, hand size, fingers, colors, just to make it as close to the real thing as possible. This kind of simulation helps prevent ergonomic related issues because everything can be validated in the virtual environment. We can identify and correct potential problems even in the design phase before the line is implemented. But if the line already exists, then we can propose and check improvements through the simulation. And as a result, we have a better product quality. We will validate the operator's posture. We will enhance ergonomics. As a result, it will also bring customer satisfaction. Okay, we'll talk about economic benefits of simulation. So let's start with discrete event simulation. So we have a cost reduction. So the discrete event simulation allow us to model complex systems like production lines or services systems without physically testing things in the real life. It means that we can predict the problems, we can see inefficiencies, and we can avoid that costly mistakes before they happen. Another thing is that we have optimized resource allocation because with discrete event simulation, we'll make sure that we are using the resources like labor, equipment, and space in a more efficient way. And this will help you reduce wasted time and it will increase the output. And user discrete event simulation, we have faster decision making because we'll be able to simulate different strategies. We are able to make quicker and smarter decisions. So we'll avoid all that trial and error process. Now let's move to the robotic simulation side, where we have increased productivity. So with robotic simulation, we can test and we can optimize the robots before we implement them in the real environment. And we will ensure that the robots work efficiently and that we get the best results from them, reducing the downtime and also increasing productivity. And then we have the reduced downtime and maintenance costs. So here, by testing robots, validating the robot paths in a virtual environment, this will help us to catch some potential issues like collisions, mechanical interfaces before they happen in the real life. So we can avoid all these unexpected breakdowns and all expensive repairs. And then we'll also have a faster time to market because robotic simulation will speed up the testing and the integration process. And the faster the robots are implemented, the quicker the business can start seeing the return on their investments. And finally, let's talk about the economic benefits of ergonomic simulation. So we have improved employee health and safety. So ergonomic simulation help companies design some safe workspaces that will reduce the risk of injury like repetitive stress or back problems. These are things that we can directly see that in the ergonomic simulation and also export ergonomic reports. And this will result in fewer work injuries, lower absenteeism, and as a consequence, we'll have happier employees. And then we have higher productivity. So when the workstations and the tools are designed for comfort, the employees can work in a more efficient way and also with less fatigue. It will result in fewer errors and we'll have a better overall performance. And we have reduced health costs because investing in the ergonomic design, it can save companies a lot in the long run by reducing the health related costs. So fewer injuries will lead to fewer healthcare claims. Great. So here I brought you 3 case studies. These are real examples. I will show you some projects that I worked on at PMC. So here on the screen, I have a case study using ergonomic simulation for a door handling fixture design for a major automotive manufacturer. And we have a challenge here. They were introducing a new car into the production line and the new door handling fixture, and they needed to know if there would be any kind of collision between the device and the car or between the device and the infrastructure. They also wanted to check operator accessibility and all the ergonomic analysis. They want a ergonomic report, and all the operator posture during the the operation. So what was our solution here? Well, we used ergonomic simulation to be able to analyze the interaction of the operator and the new door handling fixture. In this operation, the operator is placing the front door with the rear door open. But if the rear door is open more than 36 degrees, there is a collision between the operator and the rear door while installing the front door. So this was identified during the design phase, and it was pointed out to the end customer. So we made some recommendations and we presented a simulation report. So as a result of using the simulation, this showed us an improvement in reachability and a reduced risk of injury. Here on the right side, you can see we have two images here. And for this particular study, we used Process Simulate Human software from Siemens Technomatics platform. Here we have another project. We use a different software. I used a Discrete Event Simulation. It was a plant that manufactures doors. And we had another challenge here. So the client was expanding its operation, and they want to know if the plant, it was a new plant, the new plant would be able to achieve the required throughput. That was the main goal. And in addition, they wanted to see some possible bottlenecks in the line. They want to check operator utilization and optimize labor allocation, check machine utilization, all of that before purchasing the equipment. It was a greenfield here. So we received some input data like layout, processing times, work shifts, conveyor speeds, maintenance data. It means availability, MTTR, MTBF for the equipments, and also a material showing the process flow. So be able to start modeling this area. So our solution here was to use Discrete Event Simulation to model the system. In this case, within the same simulation, we can switch between 2D and 3D. As you can see in the images on the right side, on the top, we have a 3D view. On the bottom, we have the 2D view, but it's exactly the same simulation. We can run in both of them. And as a result, this simulation allows us to identify some bottlenecks. We also propose some improvements that could be made in the process. We check the ideal number of operators to run the system and also increase the production capacity. For this particular simulation, we used plant simulation software from Siemens Technomatics platform. Here we have another project where we used robotic simulation. It was for a client who was introducing a new project into an existing robotic cell. So this line already accommodated more than 5 products, and they wanted to add a 6th product and ensure that the robots could perform the operation within the required cycle time and with no collisions. So we introduced the project, the product into this project, and we started creating the trajectory of the 4 robots for this new product. And then we parameterized the trajectory with real speeds, and we ensured that it would be within the required cycle time. But we did all of this before they introduced the new product into the line, still during the planning phase. So we end up with a program without collisions within the required cycle time and ready to be imported into the real robot. So here on the right side, I have an image of the robotic cell that I'm talking about. And for this particular project, we used Siemens Technomatics platform Process Simulate software, Process Simulate Robotics. All right. So here we'll talk a little bit about return on investment. And in the context of simulation, the return on investment refers to leveraging software tools to model, simulate, and access financial returns or benefits of investments in process or projects. So simulation software allows business to predict the outcomes in various scenarios and quantify the expected benefits compared to the cost incurred by the investment. So return on investment calculation is the net profit coming from the simulation. For example, benefits gained from the use of simulation, like increased productivity, improved process, reduced downtime, and money saved, for example, minus the cost of the simulation, which would be, for example, acquisition of the software, acquisition of the license, training and maintenance, divided by the cost of the simulation and multiplied by 100. So here we have an example. Let me just move one slide. So here we have a calculation with some numbers to make it clear. So we have software license and training costs totaling $70,000. And we have net profits from the simulation. So we have increased productivity, reduced downtime. So we have $30,000, $50,000, and reduced losses and inventory costs of $40,000. So we have a total of $120,000 in net profit. This is an example. Okay. So just putting these numbers into the formula, the return on investment for the simulation implementation is 71.4%. This means that the investment in the simulation is expected to generate a return that is 71.4% higher than the initial cost. So this is a positive return that shows the benefits of the simulation over the costs. It says for every $1 spent on the simulation, the company is earning back $1.71 in profit. So we can see that this is a healthy return, and it's showing us that this is a worthwhile investment. And here we have some justifications. I brought you some key points. So we have upfront costs versus long-term gains. So we know that the initial investment in simulation can include the licensing costs, license fees, trainings, and all the implementation costs. But the long-term return on investment comes from the increased efficiency, for example, or reduction in downtime, for example, and optimize the resource allocation, as an example. We have cost savings, for example, the simulation can lead to reductions in material waste, energy costs, or labor inefficiencies, if we're talking about discrete event simulation, as an example. So we have savings in productions. So we are optimizing the workflows. The company is saving money from energy costs or inventory management, and also having production improvements. And then we have productivity improvements that will lead us to faster decision making and the process optimization. And I can say shorter production cycles and reduce the lead time. We have risk mitigation. So we can see that the simulation helps us identify potential risks in the process, but before they occur. So the early detection of bottlenecks or the inefficiencies, for example, will save the company from this trial and error in the real life that will cost a lot. And we have intangible benefits. Here I can say customer satisfaction, for example, because faster production times and a higher quality product, it will lead to a better customer experience. Overcoming common objections. Okay, so this can be crucial for ensuring a successful adoption of simulation. So let me show you how we can address some of these typical objections. So we have objection one. Simulation software is too expensive. Okay, this is a big one, right? A lot of people think that the simulation software comes with a price tag, and yes, it comes. There is an initial investment, but the save down the road can far outweigh that, because firstly, we have cost saves in the long term. You are reducing the need for physical prototype and costly testings. You also get to optimize designs and process, which means that you are using fewer resources and materials. So while there is an upfront cost, the return on investment can be huge over time. Okay, but it's too complex to learn and to implement. Yes, this is a concern that I hear a lot. because people are worried about this learning curve. And here's the thing, the modern simulation software is designed with the user in mind. So many platforms nowadays have intuitive interfaces that make it easier to use it, even for beginners. For example, there's a plenty of material available on the internet, on YouTube. Um, you can also access some examples, small examples from the simulation itself, and also user guides, just to help you get up and running. And the best part is that you don't need to master the whole simulation software in one go. You can just start small, right, with simple simulations. So in this way, you can gradually improve your skills. All right, but our processes are too unique for simulation to be effective. All right, this is a really common concern, and I completely understand, because when you are dealing with process that you feel that one of a kind or customized to your specific needs, it might seem that the simulation tool just won't apply. But here's the thing, the simulation software is very flexible. It can be tailored to fit a wide range of unique processes, so don't worry about that. Okay, but we don't have time to implement simulation right now. Well, this one is all about thinking in the long term. Uh, yes, there is a learning curve up front, but in the long run, the simulation can actually save you time, because by identifying the potential problems early in the planning phase, you can avoid costly mistakes down the line. So instead of waiting for prototypes or testing cycles, you can make adjustments quickly and see the results instantly. Okay, but simulation doesn't reflect real world complexity. This is another common concern. It's totally understandable. But we have the idea that the simulation will oversimplify or will fail to capture all the variables that we have in the real world situation. It's something that many people worry about. But here's the thing, the simulation software has evolved a lot over the years, and now it's more capable of reflecting this real world complexity than ever before. So we have realistic modeling, and the simulation are based on real data. So I can say that many simulation tools come with the ability to validate the results against the real world outcomes. So you can test your simulations in parallel with some physical trials to see how close the results are. And if they're off, you can just go back to the simulation model, you can adjust it, make it more reflective of the real world complexity. And this is crucial. This kind of feedback loop between simulation and the real world testing, this is crucial for continuous improvement. Okay. So here we have our conclusion for today's webinar. And just to wrap it up, I can say that the simulation is a powerful tool um, that will help you save costs, improve safety, and boost productivity. So by virtually testing your manufacturing process, you can optimize performance, you can reduce risks, and avoid all these costly mistakes. At PMC, we are here to guide you through these improvements, ensuring that your operations run smoothly and efficiently. So if you have any questions or if you want to explore how the simulation can benefit your specific needs, just feel free to reach out, and we'll be excited to help you. So let's quickly recap what we have covered today. So we started with an overview of simulation, just giving you an understand of how it works. We looked at the features and capabilities. We discussed the economic benefits of using simulation. We had the real world examples and case studies just to show you how it helped our customers. We covered ROI calculation and ROI justification. We tackled some common objections as well. And of course, we concluded highlighting how simulation can optimize your manufacturing processes. Well, we covered a lot today, and I'd like to hear if you have any thoughts or any questions. So I'll get back to you, Veronica.
Awesome. Thank you, Caur. We did have a question come in over the Q&A feature. So yes, please use the Q&A feature. So from all of your experience with discrete event simulation, what is the biggest challenges or difficulties to get good inputs to develop a model? So I guess they're asking what are the hurdles that you have to overcome to get good inputs so that your results are reliable?
Okay. One of the biggest challenges is ensuring that we have um, reliable data, right? The simulation is only as good as the data that we are adding into it. So it's crucial to have centralized, clean, standardized data to use in the simulation software. So you might invest in tools that can pull together data from different sources, just to make sure that you are using up-to-date data and constant information into your simulations. This is one challenge that I can see. Um, Another challenge that we can see is resistance to change, especially from employees and leadership that were using traditional methods for decision making process, or Excel, for example. So overcoming this resistance, it will require communication and effective training. But we can start small, start with a small pilot project. This will be a great way to demonstrate the value of the simulation, right? Or to build confidence and then start gradually scaling it across the organization. I can see these two challenges, Veronica, just answering the question.
Gotcha. Thank you. Another question that came in here. What are the main challenges that businesses face when integrating simulation into existing operations, and how can they overcome them?
Okay. This can be also related to, I can also relate that to the data, but uh, I have some advices to give to business. For example, my first piece of advice um, is to set a clear and specific goals to the simulation projects. So you need to know exactly what problem you are trying to solve or what result you are hoping to achieve, for example, whether it's improving efficiency or cutting costs, optimize process. If we are talking about ergonomic simulation, boosting safety, for example, because if you don't have a defined objective, it will be easy for you to get lost in the complexity of the simulation. And as I commented previously, uh, the data play a really important role in the simulation.
Okay. And this last question, what advice can you give to someone just starting to consider simulation in their company? I think they're asking for kind of the more pitfalls here.
Okay, I can say that a good plan here is to just to start small. As I just said through the webinar, it's good to begin with a pilot project or just apply the simulation to a specific process or to a specific area. Just to start it small, because this will give you the opportunity to learn the tool. That's what is important in this moment. Before you diving into a larger and a more expensive initiative, for example, And it will also help you build confidence. It will also help you create experience. So yeah, these are the advices that I can give.
Okay, excellent advice. Thank you, Kaur. I don't see any other questions, but please feel free to email Kaur or marketing@pmcorp.com. We can also assist you with any further questions, and we will be sending you a recording of this webinar later today. So thank you all for attending. Thank you, Kaur.
Thank you, Veronica. Thank you, everyone. Have a great day.